In exercise 4B, we're going to see those nice new formulas for calculating aspects of a circle, including the length of an arc, the area of a sector, and the area of a segment. However, these formulas can only be used when the angle at the centre of the circle, and all of these require an angle at the centre. An arc is formed by an angle at the centre. A sector is formed also by an angle at the centre, and the same with a segment. If that angle is measured in radians, we can use these formulas. And of course, if the angle is not given in radians, then we convert from degrees to radians and then use the formula. So this formula is on the reference sheet, and it says L, which is the arc length, is equal to R times theta. Very simple. The radius times the angle, where theta must be expressed in radians. That is pretty straightforward. I'll come back and fill out this example and show you that in a moment. But firstly, I want to show you that there are 3 formulas. So there's that one, and there's various applications of that formula. The second one is calculating the area of a sector. So you can see I've shaded here this whole sector. It's formed, like I said, by an angle at the centre, which we will call theta, and again theta must be expressed in radians for you to be able to use this formula. The formula is that the area of a sector is a half times the radius squared times the theta, where theta is expressed in radians. And of course it's units squared because it's area. So you'll see that there's a couple of examples there. Oh, well, there's only one, but there's also some in the other part of the OneNote. The third formula is for calculating the area of a minor segment. You can see here that I've shaded what a minor segment is. A segment's produced between a chord and the circle. Now, you can simply, and it involves an angle at the centre of the circle, which we're going to call theta, and theta must be measured in radians, and the area of that minor segment is a half times the radius squared bracket theta. Now that theta must be in radians. It will most likely have a pi in it because most angular measure in radians involves pi minus the sine of that angle. And the questions that you often get testing this formula have the angles of 30, 45 or 60 degrees, because you can find the exact ratio of the sine of that angle. And again, the units are squared because it's a measurement of area. I will stop the video there, and in the next video I will do the examples using each one of those formulas and talk you through the solution.